All right, in this video, we're going to go over the Lesson 1 Colab. My recommendation, go to your calendar, click on Lesson 1, and then in the notes, all the way at the bottom, there has the task that we were going to do that day if we had time, and the key. Personally, I'll be using the key to talk through it, but you should be using your own data that you have from the in-class trials that we did with the dice rolls, and then when you get to listen to the Smarties. All right, so it says import matplotlib, pandas, seaborn, and numpy. Numpy is a new library that is going to allow us to do random number generation. Matplotlib, pandas, seaborn, and numpy, or numpy, I don't know. You're rolling those dice 10 times. You can just pull out the paper that you had from before. Those are the dice rolls. Oops. Go ahead and run our libraries and trial, make sure there's no errors. Now to calculate the average, do numpy.mean of our trial. And if you don't want this part, you can print it. The average roll was a 4.2, a little high. Let's make a histogram. You can use Seaborn for this. If you want, you can use matplotlib. Honestly, though, I like Seaborn better. Using our trials, and then having discrete numbers. So like this part, discrete are just countable numbers. And there's all of my rolls. Looks like it, yeah, it was a little high. Yours should look different. Using your paper, you had the 2 dice rolls, and then you found the averages, and then you found the averages of the other students. So let's make a data frame of those sample means. Your numbers should be different because you did this in class. Pull out your paper from before. Pause the video while you type it in. And then a very simple hisplot. Why did I not do the discrete equals true? Well, this time we were calculating the exact numbers, but now I want the decimals because we have our averages. It's a little different. There we go. It's easier to see. Now you could put an axis and a title and all that stuff, but this is just for demonstration. Now, we're going to use a random number generator and just have it roll a whole bunch of dice for us all at once. I was not going to make you do this 50 times. That would be crazy, especially when you have a computer that can do it for you. So it's going to roll between 1 and 6. I don't know why it includes 1 but excludes the 6. That's just how they programmed it. The first number in the size of your random generation is how many times you repeat the process, and then that 10 is how many times you rolled the 10-sided dice, or the 6-sided dice. So you rolled the 6-sided dice 10 times, found the average, and then repeated that process of finding the average 50 times. So you did it twice, finding the averages, and then polled the class. This does it 50 times. And it's going to get a little bit closer to that normal distribution. Ours is a little bit choppy. 3.5 is still in the middle though, which theoretically should be the average. What happens if we did it 100 and then found the average instead of just 10? Like you rolled 100 times and then found the average. So I'm just going to copy this. I don't feel like typing it over again, and y'all could do that too. What number are we going to change? We're going to change samples of 10. Instead of finding the average 50 times, we're going to find the average 100 times. And it's looking a little bit more like a normal distribution. What if we did it 1,000 times? Pretty good. You can see the theoretical average is around 3.5. It's looking a lot more like that normal distribution. Now let's go to in your notes when you had the 2 dice. Before we just did 1 dice, now we're doing 2. And we have the different sums where you added those 2 dice together. You have your own data. It'll look different than mine. There's all my sums. And let's make a histogram of those sums. And since these are whole numbers, discrete numbers, we'll say discrete equals true. Okay. So 7 was the most common, which makes sense. When you roll 2 dice, that is theoretically the most common, although I did have a high number of 2s and 12s, more than you would expect. On your paper, we should have expected maybe 1. We had that like probability. And what would happen if we did more trials? It gets more like a normal distribution. Now, this particular one that I ran has a lot of 4s. Yours might look a little different, but it's still getting closer to that normal distribution. What if, let's do it again. What if we did it 1,000 times, or 100 times, or 500 times, or whatever? Let's just change the size. 100 times. Oh, interesting. 500. Each time when we do more trials, it's not perfect. Statistically, there will be some sort of variance in how they rolls, but we're getting closer and closer to that normal distribution. And once we got to 1,000 times of finding those sum dice rolls, we are very close to the theoretical probability of each number. That is your law of large numbers. If you just keep rolling, you're going to get closer and closer. Like, so this was pretty scattered, getting closer, very close to the normal distribution. Like, this is exactly what you would expect from each one. And that's the day 1 Colab that I'm expecting you to do. So if you go to your classwork, sampling, make sure you have completed both.